Thank you so much for joining me today. I really appreciate your time. As Mike said, my name's Keith Atherton. I'm a Power Platform Solution Architect at Capgemini. The session we're going to have today is Full Power App Optimization. So as with Mike, I'm based in the UK. There's a little bit of a time difference, so I really appreciate you all spending time with us today on our sessions. It's very much appreciated. So let's make a start. A bit more about me. Again, Power Platform Architect. I'm a professional developer by background. I've been around a bit. I've got over 25 years experience at this stage, mostly with full stack development, web development, mobile apps, and so on, and then moved over to the Power Platform about 3 years ago. Since then, I've been lucky enough to become a Microsoft MVP, just as with Mike Hartley and many other speakers that we have throughout this event. I'm also a Microsoft certified trainer, a LinkedIn learning instructor, and I get up to other things like running a podcast and a user group as well. So it's all busy but fun stuff. It's all great, and I just love connecting with the community. So if you love connecting too, please do connect with me on LinkedIn. That way, if you see anything cool or you've got any questions later on, or you think of something later on, you can just hit me anytime on LinkedIn Messenger. I'm always happy to help people out. So yeah, please do that. As Mike finished with his as well, you will see this several times throughout the event, but it's super important that the sponsors are really allowing us to have wonderful events like this. And I know that the community is really strong in New Zealand, so we're super grateful that we're getting great support from companies like Stratos, Dynamics User Group, H2R Technology, Teal Software, Elevate 365, and Microsoft themselves as well. So again, goes a really long way in supporting these wonderful events that are free or affordable for many of us as well. So massive thanks to them. So what we're going to cover today, we're going to cover a few things about code optimization, architectural optimization. Might sound a bit big and fancy, but sometimes it's the simpler concepts we'll look into. Some user experience or UX considerations we need to think about, and monitoring and troubleshooting. So there are only a few different topics that we're going to cover, but I'm going to share a lot of information. I really want everyone here to get as much value and benefit out of this session because our time's precious. I know within an hour I can share a lot, but the reason I'm going to share a lot as well is because you might know some of these tips and tricks already. So maybe there'll be some hidden gems in there that'll be useful for you all, and that's maybe where you'll get the value. So I'm going to share as much as I can in the time that we've got. That's my challenge. So first up, we'll talk about why we'd want to optimize. Now, a lot of things out there, of course, we want them to run fast. We want them to be slick. We don't want to be stuck on a screen that's taking minutes to navigate between screens, or for something to load, or clicking a button that takes 20 seconds to perform an action. But taking a step back from that, think about why we'd want to optimize is really we want to improve that user experience, and then we're going to get an improved user satisfaction. And the key to all this is to improve the user adoption. Now, I'm working on a project at the moment for a big government client in the UK here, and we're looking about adopting the Power Platform at scale within this organization, tens of thousands of users who work for this big organization. And really, we want the apps and other solutions. It's not always just an app. We want them to be enjoyable to use if we can. We want them to be a pleasurable experience where they might say, hey, check out this app, it's really cool, look what happens when you do this, or hey, this has just saved me so much time this week and it's been easy to use. I don't need a user guide, it's straightforward, it's intuitive. So really, we want the user adoption to go well and for us to get good feedback and for people to be happy when they use these systems. There also might be cases, now for me this has been quite rare, but it can come up, is that you might get non-functional requirements or NFRs on your project that might dictate some of these performance metrics. So they might say, we've had an app delivered by another partner in the past, we were kind of stung by it, we weren't impressed. the app took over a minute to load. It was awful. We didn't like it. People were unhappy. They might actually have some of these in the spec to say, well, the app must load within 10 seconds. They might say when we click on a button or go to another page, it must complete within 2 seconds. They might have some kind of metrics in mind. Again, this is quite rare for me, but there are some out there where they might have to be specific to say, we really want this kind of behavioral experience. Some of my background, I've worked in different industries. One of them was game development. Now, many of us might know that there might be numbers that you hear out there in the industry where, hey, we want games that run at 60 frames per second or faster. Now, often this is because, you know, lots of studies have found that that's a really smooth, slick experience for many games. We don't want things that kind of jutter and stutter around and take a while to load. So there are reasons that there are metrics like that out there. I'll briefly just mention as well, there are actually some performance models out there that have been documented that do measure some of these things. So one of the common ones is the Rail performance model. This was developed by the Google Chrome dev team actually a few years ago, and they measure things. So Rail stands for response, animation, idle, and load. Without getting into the detail, it just means, hey, the response, when you click on something, I want it to respond within a certain amount of time and not just hang with, you know, sort of a progress bar or a spinner and go white screen for 20 seconds. I want some kind of fast experience. Same with load. I want the app to load within so many seconds. So these are things that they've done focus groups and research to find out what makes a good user experience. So if you're interested in this topic and you want to learn more, it's worth checking out this Rail performance model. So let's dig into the good stuff. So what we're here to do is the first subject is code optimization. So one of the things I'll talk about first is the app on start property. So if you're on Teams now and you can give the thumbs up, please give me a thumbs up if you're familiar with the app on start property. If this is something you've seen before, if this is something you've used, yeah, please just give me a little thumbs up on Teams just to let me know that this is something that you've seen. Awesome. Great stuff. Thank you. So the app on start property runs when the user starts the app. So the example in the screenshot there in the very top right, it's not doing very much, but it's setting a global variable X to a value of 1. This is just for a demo. It's not really doing anything valuable. And you can actually run this by going to the app object and clicking run on start. Now, sometimes this is fine, but sometimes if I just go here to this link, let me go ahead and share this screen. I'll share the entire screen so we can see this link. Here we go. Fantastic. It'll just take a moment there. So I've just gone to Microsoft Learn. Now, the reason I've done this is even Microsoft themselves say in the on-start property for the app, they even have a warning that, look, this can cause performance problems when loading an app. Even they're aware that this might be something that if you do too much work in there, because with Canvas apps, we've got the freedom to put work in there might be a good chance we start doing too much in there, or over time it grows and grows and we do more and more work, like grabbing more data, running calculations, setting variables. And actually, before you know it, that 1 second to load might become 10, 30, 60 seconds to load. So something for us to be aware of, and it's known in programming as an anti-pattern. So what I'm going to do is just give a run through some alternatives we've got with app on start. So right here, I've just got a very straightforward, basic looking app. And if I, again, go to the app object and to on start, I'm just going to expand this. And right here, I've got some code that's doing some work. Now, the main bit is the bit I'm highlighting right here. This is some kind of like meaningless slow code. What this is really doing is nothing useful. This is just doing a really big for all loop 50,000 times, and it's generating a lot of random numbers. It's not actually useful. I just want something to take a few seconds for the purpose of this demo. It actually doesn't do anything useful for us. So if I go ahead and give the on start a run, it's actually frozen the screen for a few seconds there. And if we zoom in, I've got a message telling me that took over 4 seconds to run. So right now, if this was when the app loads, the users had to wait for over 4 seconds before they see this first screen. So we're going to look at some alternatives to this, some other things that we can do to improve this experience. So what we can do is, let's say, instead of the work when the app loads, let's make it load fast. When I then click on a button to navigate between screens, in this case to a second screen, again, we can still see it took over 4 seconds. So again, it's not exactly to the millisecond, but it's in the similar ballpark. But what I've done there is move the workload, doing the same kind of work, but when we navigate to that second screen. So the app's load quick, but the navigation to the second screen is where the performance hit takes place. So right here on the second screen, go to the onVisible property. All I've done is just move that workload to there. So again, I've not made anything faster. I've just redistributed where this work takes place. And again, this would be useful if you want the app to load fast, but the performance hit to take, to be done elsewhere. So that is one option, just to move where we do it. Another option is to use a named formula. So in this example, I'm on a screen, I'm going to click a button, it's working away. That's why the button's frozen, by the way. It's taking a few seconds. And then when it's done, again, I'm going to notify to the screen this took over 4 seconds. Again, nothing's been improved, nothing's been made faster. I've just moved where the workload is being done. And again, depending on what user experience we're looking for, it may be that we do want it on when the app loads, or we do want it when the button's being clicked. So in this case, if I go to see what happens when the button was clicked, this is what happens on the onSelect event. I'm actually building a collection, but really the highlighted part there, this NF work, this named formula, that's where the actual work is being performed. So all I've done is just move this to a different place and called it on demand when I need it. So if we go back to the app object, the formulas property, and expand this, there's that NF work that we talked about. All this is doing is building up a big collection. Again, this is known as a named formula. So it's been around, for a little while now, generally available, ready to use. But we can see there, I'm doing the same workload, but I'm just calling it when I need to call it. Not when the app loads, not when the screen loads, just when I need it. There's also another similar option we've got called a user-defined function. And just to give this a run, we've got something here with the Fahrenheit with the text input, and then the Celsius being the output. So something where if I change the value in this Fahrenheit, we're actually changing the text label for Celsius and displaying the result of a user-defined function. So this is something that immediately takes effect when we call it, and is very, very useful. Excuse me. So this is a bit like the named formula, and if we take a look at what the code's happening there behind this text label, this is what the code looks like. So nothing too rocket science. We've got the name of a function, just as if we called value or round. UDF, user-defined function. I've called it convert Fahrenheit Celsius to keep it readable. I'm then bringing in the text value for the Fahrenheit text input, converting it to a number by using value, and then I round it to 1 decimal place just to keep it readable. But really calling that user-defined function, that's what's doing the work. So where that takes place is if we go to the app object formulas again, where that named formula was, this is this user-defined function below. Now, what I've got there is a meaningful name, UDF convert Fahrenheit Celsius. I pass in Fahrenheit. I'm going to call it F, this variable. It's a number, so I've specified the type. I've specified the output as a number, and I have this PowerFX formula, which just does that conversion. There's nothing too heavy going here. This is just for the purposes to show that, like a named formula, we can actually do some work, but the big benefit with this user-defined function, if I just go back a moment there, we can actually see we're passing parameters in. With a named formula, we can't do that. So it's good, but there's a slight restriction to it. If we want to do something, and admittedly, it looks a bit more code-like, a bit more pro-dev-like, but there are more flexible options because we can pass multiple parameters in if we wish, which means it's a lot more flexible, a lot more reusable. So it's a really, really great option to use. So we covered a lot there just in that first one, right? But the app on start, so we don't always need a slow start to the app. We can redistribute the workload, and we'll come on some other tips and tricks later on that can actually speed up the workload, make it a faster experience as well. By the way, when I was notifying to the screen, I had a little pop-up there with a this notification saying it took 4.7 blah blah seconds. So with the organizer's help, I'm going to try and share these slides, so you don't need to take notes or screenshots unless you want to. But just to explain what this notification did, it's just a piece of Power Effects that I've written, and it works like this. So the line there, I'm just actually taking a snapshot of the current date time. I then run my piece of code, which would be where this comment is right here. Then right here, I actually get the time difference in milliseconds between when it's finished and the original time. And then I just notify to the screen, say it's done, or duration, whatever I want to do. And I actually just format it to put it in this kind of format with 3 decimal places in this case. So there are other ways we can monitor performance and get these kind of durations back. But I find this quite useful to say, just give me a snapshot. How long did this page of code take? And that way, if I start messing with the code and tweaking it, I can check before versus after. Have I actually improved the performance, or have I made it worse? So it can be quite useful. So another one I'm just going to ask there on Teams, if everyone can give me a thumbs up. Has anyone here come across the concurrent function before? Just want to see if this is something on people's radar or if it's something new. Fantastic. Okay, thanks, Kashif. That's awesome. Great stuff. Okay, perfect. So just a bit of background with this one. I'm going to walk through the process. This piece of code with the 4 lines, we're actually going to gather 4 collections in order from tables called product, customer, sales order detail, and sales order header. It's just an example. So when we run this, and if we check the network traffic when this is performed, we'd see something like this, where that pull from the product table into a collection, that's that very first line that we've got across the top with time running horizontally. Now, only when that's complete would line 2 take place to gather the customer records, and then the 3rd table, and then the 4th. So as we'd expect, the lines are performed in order, and it's only when they complete do we move to the next line. However, we can improve this. So if these lines of code are not dependent upon each other, we can actually say run them all at the same time. We can actually wrap them with this concurrent function, which I've highlighted in yellow right here. So all I'm doing is saying do all the same work again, but if you run them concurrently, in other words in parallel, we're kicking them off around the same time. So right here, we don't need to wait for line 1 before we do line 2. We just want them all done. So in this case, if we look at the graph of what's going to happen, they're all going to kick off around the same time, and in total, they're going to complete much quicker. So they're doing the same work, but it's going to complete faster. So again, if this was something like when the app loads or something like that, we can see in this case, this example, every example would be different, every use case. But in this one, it's maybe half the time it takes to do the same workload. So it could just be a quick win just for the sake of using this function. So for any kind of heavy lifting, things like this, where we gather lots of data from tables, or anything we find takes a long time to run, to complete, they're the quick wins. But, it's more useful there than, say, just setting a variable to a value of 0 or value of 1. We probably wouldn't get much performance benefit. But anything heavy lifting that can be done in any order is a good place to use it. So there we looked at collections, but let's look at some variable types. So we've got global variables, where we use this set function in this case, where we're setting pet name to Oscar. Oscar used to be my dog, by the way. Context variables, now the context, that's in the context of the screen that we're on. So it's going to be a scope of only that screen, and when we move screens, we won't have access to that. So in this case, energy level set to 100 using the update context function. And collections, which we saw on the previous one, where they do have an app scope, we can access them like the global variables anywhere in the app. And in this case, I'm bringing the accounts table in its entirety back to a collection called col accounts. So the short version of this is really just focused on the variable types that are most relevant. If you need something that is needed on multiple screens throughout the app, and it's just a single value, using that global variable at the top could be useful. If you only need it for that screen, that context variable is ideal. That way we're not holding it in this memory that builds and builds and builds if all we do is need it on that single screen. And the collection is if we've got a table full of data. Another type of variable I want to cover is with the with functions, so that's not confusing, right? But the with functions, there's an example there we've got on the screen there. So these have a formula block scope. So in other words, for the example we're seeing on the screen, when we're finished with this formula, in other words, that very last semicolon, all the variables used within this are dropped from memory. We don't need them anymore. So in this case, what we're doing is saying, do a lookup on the users table for the signed in user, bring back their title, save it in this record with a field called title, and then we set a global variable afterwards. But when we're done, that title and that record in the with block is just dropped from memory. So it's cleared from memory. So it's very, very kind of efficient. It means we're not building up memory and making the app go slow over long periods of time. So again, as I said, these records are cleared automatically from memory when the execution is complete. And you can make them a bit more complex and nest with functions within themselves as well. So you can actually build them up and make them complex if you want to. Another thing to cover with these with function records to do with this session as well is that they can massively improve performance if the record values are referred to multiple times. So the example we've got right there, the with block, we're actually building up this record and we've actually got 3 variables being set. So we're getting a title, a first name and a last name. And as we can see in each case, we're doing a lookup to the users table for that signed in user, and we're bringing back each one of them, that title, first name and last name. So when we do that, we then set global variables to them afterwards. There's nothing complex here. It's just a basic example for demo. However, because those 3 calls are doing the same network calls to the same place, we can actually consolidate them into one call. Now, because data source calls can often be the most performance heavy, because we're going over a network to retrieve data, sometimes many records of data, this reformatting I've got at the bottom there, we're doing a single call to get the entire record back, and then we just pluck those 3 variables, those 3 fields from that one record. So we've reduced 3 data source calls down to 1 just by refactoring our code. The other benefit with this as well is because we split this PowerFX into multiple different statements instead of one big gnarly complex one with brackets everywhere that runs over one line. We can improve the readability too because we've broken it down into manageable chunks. So there's kind of a win-win using these with functions. Very, very useful. So another thing I want to cover as well is the lookup function. So this is something I've used before to say, look, I need to go to a table. I want to get one record back ideally and just bring some values back from it. Sometimes just one value, just one of the columns I need. So in this example on the screen, I'm actually doing a lookup on the users table, again for that signed in user. I'm bringing back the whole user record, so I've got all the fields, and then afterwards I set the global variable user title to just the title field. I don't need any others, don't use any others, but that's the way it's done. First glance, this looks good, but I'd say that first call, in this case, I'm bringing the entire record back, all of those columns, but at the end of the day, I only need one of the columns. So I've kind of gone a bit overkill here. I've used way too much. So I'm only seeing some of the columns there, but I know the users table has over 100 columns. We might be bringing back more data than we need to, which makes it slower. There's no need for me to bring 100 plus columns back. I just need one. So one thing I discovered a bit later in my journey with Power Apps and PowerFX was that this lookup function that we might call, it's got a reduction formula. The syntax on the top right, we can see there, I do a lookup on this table. Here's my formula to kind of filter it to get that one record, but there's also this reduction formula. It's in square brackets, it's an optional parameter that we can pass in. And this passed me by, I just didn't know it. I just kept seeing on the forums all the examples of lookups. I never saw this reduction formula, it's brand new to me. So if you do set this, a single value comes back. And again, you can reference columns within the table. But if you don't set this optional one, that entire record comes back, which might just be too much. It might be more than we need. It might be going slower than we need just because, we're not setting this reduction formula. So when I go back to the previous screen, looking at this example right here, again, I bring the full user record back just to get one field, which is the title one. There's an improvement here. If I reformatted the code to this second example at the bottom, what I'm doing is setting this optional reduction formula parameter, this third parameter, to say, look, I know I only need the title. Just give me that title. That's all I need, right? So instead of me bring the full thing back and then get the title, this is going to be smart to say, oh, you've only asked for that one thing. I'll just bring you that one thing back. Much faster, and it's much more relevant, the data that we pull as well. So in terms of retrieving data from sources, again, these can be some of the heavier lifting things that we do in Power Apps in many occasions. Let's go back to our favorite Dataverse table, the user table. We've got a small snapshot here of some of those system users that we've got there. And again, as I mentioned, some of these tables, particularly some of those common data model system generated tables like user, accounts, contacts, they might come with many columns, like many more than I'm used to when I used to be a database developer with SQL Server and Oracle database. So in this case, again, we can see there's 124 more columns. There's a lot of columns here. Many of them I won't be using. So if I go here and say, well, look, I just want the columns I need, right? I'm seeing all these things about business units created by, modified. Fine, I don't need it. But if I do this call in the top left there, the clear collect, bringing all the users back to a collection called call users, I know I'm bringing back all of this stuff. But what happens if I only need a couple of columns, let's say full name and email address? I don't need to bring 127 back. I just need 2 of them coming back. So you can do this. So if you do this and say, well, I want to specify show columns, I might say, well, only give me these columns I care about in my results that get returned. So in this case, I said, look, I only need full name and primary email. Just bring me those 2. It won't bring all the others back, just the ones you care about. Much faster. And if you're looking at hundreds or thousands of records, it can be much, much faster. Now, one note I'll mention about this as well is that Power Apps do try and help us. So Microsoft built in something here called explicit column selection, or ECS. Now, this automatically computes which columns that you need, and it tries to help us by only bringing them back. So if we had a screen in a Canvas app and we had the full name and email address as labels there pointing to that data, Power Apps will try and be helpful and use this ECS thing to say, I'll just bring you those 2 back. I know that you're not looking for business unit and all these other things. I've found in the past, I don't know about recently, that sometimes it's still not brought back the columns I need. It's just been a bit hit or miss, and I've still had issues to try and force those columns to come back. So I would say that when we use show columns, we're the ones being specific to say, no, these are the ones, definitely bring them back. Sometimes the ECS has not brought them back. It's brought them back blank, which is then kind of come up as a bug later on. So yeah, it's worth bearing in mind. Now we talked about the columns that we need. Let's look at the rows that we need from these data sources as well. So again, this example there, I'm going to bring everything back from the users table into a collection. In this case, there's 146 rows. All right, it's not the end of the world, but some tables can be bigger and it could take long to bring them back. Whereas if I actually use some filtering here to say, okay, I've got some flags saying is staff, and I'm checking if it's true, I'm only bringing back 17 rows, but they're the only 17 I care about. So I've been very targeted and reduced that data set that's come back. So again, I'm only bringing back the relevant data, but if it's a filtered data set, it's likely going to be quicker as well because there's less rows. You can also do this in galleries as well. Again, I was a little late to the party after learning about Power Apps and just picked up these little tips and tricks here and there. But if you actually hook up the users table to the gallery right here, again, it's going to bring them all back, which may or may not be what we want to achieve. But if you did want to filter and you had a view, a Dataverse view, here I can say, okay, I've actually specified the view of enabled users. Again, I'm only bringing back these 17 relevant ones that I care about as well. So this concept of using views is great because you filtered the data at the strong, powerful database, the data source, and then only brought the relevant data over the network into your client app. And while I've mentioned views here in the context of Dataverse, many other relational database systems like SQL Server and Oracle Database, they also have this concept of views as well and have for many years. And it's very similar in that you can filter the data, you can choose which columns you want, you can sort the data. And in some of those some of those powerful database systems, I should say, you've got other options as well when you bring that data back. There are some other little sneaky ways you can bring data back as well, sometimes to beat any kind of record limits, or you want to offload the work from the Power App to somewhere else. And by one of those ways, you can call Power Automate. So the example there, I'm just going to the accounts table. I've specified the columns I want. I've got some filtering and sorting going on and a bit more work. And actually, I'm then using that Power Automate flow to actually pull that data from Dataverse and bring it in. Should keep the Power App more responsive, in theory, because we've offloaded the work somewhere else to say just bring the data back when it's ready. The cost that we get with that is there can be a bit of a performance hit because we've actually called a separate process, Power Automate, to do this work, and a separate process needs its own memory and memory allocation, and work has to be done. So while it is an option, it's not a yes or a no. It depends what use case you have. It is an option to try and, bring stuff back, but keep the app itself responsive while something else is working away doing the work for you. So just floating that out there. Another thing as well, from my background as a game developer a while ago, and again, performance was massively critical there, which is where a lot of these tips and tricks have come from, to be honest, is, what kind of things did I do in the pro dev world that I can bring to the low code world? Maybe one day, or maybe it's happening now to an extent, it could be in the vibe code world as well, but may not always be the case out of the box unless we specify. One of them is caching data. So caching is just a fancy word for saying that you're storing that data in local memory in the app itself. So if I go all the way over the network to Dataverse and bring the records back, it's not cached. I'm actually just grabbing it each time. If I bring them back and then store them in the app itself and keep it ready and local, I'm caching it to be used in the app. So you can actually do this by bringing the data back and saving it to local variables, the variables we covered. So in this case, I'm bringing back the user record to a global variable. I'm actually storing it in global user. Here, I'm using that reduction formula that we talked about earlier on just to bring back a single value into global user title. And you can bring a collection back as well. So again, if we call these local variables and collections, we're not going all the way over the network to retrieve this data. We're actually just calling it local, and it is always much faster because we're not doing the network trips to get the data. Doesn't matter if it's in Dataverse or if it's in the same region you're in, or the data's the other side of the world. If you're getting it straight from the Power App, we've not had to make any network calls, and it's much faster. Again, I'm a consultant, right? So it depends. It's not always a perfect fit. We've got to consider things about like how often does that data change. I used to work in retail, and we'd have a branch, a list of branches throughout the UK of over 100 stores, and they would open up a new store once every few months. So sometimes you might say, well, I can get this branch list once at the start of the day when the app loads. I don't really need to keep refreshing it constantly throughout the day because we don't open up new stores every 10 minutes. That might be a case we can get away with this. But there might be cases where if we need real-time data or the latest sales figures, and they do change on a regular basis, we might have no option but to go over the network to make sure we get the freshest data to make those business decisions. So it really depends on your use case. There's also a really neat trick on patching records very, very fast. So the example, and this I always used to do this way on the left-hand side, and it still has its place, it's great, is I've got a collection of records, let's call it call accounts. I'm going to loop through them using this for all loop, and then we're going to do a patch for each one of those records one by one as I go through them. This works great, and again, it's doing them in sequence, a bit like what we saw with the concurrent example. It's doing them non-concurrently, one by one, but we can kind of take a concurrent effect like this right-hand side, which is actually less code as well, by using something called the schema match approach. And there are many good blog posts and Microsoft Learn articles that explain how to do this. The reason they call it schema match is that our collection, call accounts, we've matched the schema of the accounts table, we've matched the structure with all the columns it's got, certainly all the required columns, and that actually if we call this, again, all these kind of patches get done and kick off at the same time simultaneously. They're not done walked through one by one, which again, if you've got a large collection, many records can take a long time. So again, another good way of getting performance benefit, and it's less code. It's great. So just going to finish up with a few random little nuggets and gems here. Things like over-engineered designs. I was a pro dev for many years. I've seen lots of over-engineered stuff, believe me, lots of kind of funky stuff or clever code that does really algorithms and lots of loops and lots of clever things. Sometimes that can slow things down. So things to avoid, things like cross-screen dependencies. So if one screen in your Canvas app is referring to variables or controls in another screen, it means that other screen needs to be entirely loaded into memory for it to be accessible, which means it's doing a lot of heavy lifting and putting things into memory. It's better just to use a global variable or using context variables that you pass when you navigate between screens. You can get clever and nest galleries within other galleries, but often the performance and sometimes the accessibility is awful. So you really want to avoid this if you can. Often you can make galleries show and hide or expand and collapse as you need to anyway, and make them complex just in a single gallery. So we don't need to go there in most cases. Galleries have got things like all items count, which just get you a count of the records in a gallery, quite useful and convenient. Screen transitions, I've found that on slower devices or slower network connections, and some users, depending on location or where they're based in the world or what kind of infrastructure they have, sometimes I find that transitions like fade and others with their basic animations can actually be a bit juddery and stutter a little bit as well, and it gives a bit of a poor user experience. So often just going with the default of none, we don't really need a little animation to jump between a screen, is often the better approach. Sometimes I use timers. I've messed around with games or like auto refreshing, data sources and things like this. Sometimes using too many, I've realized that I can actually slow the app down and again, make it stutter a bit. So something to avoid. Again, along those lines I just mentioned there, refreshing the data sources. Does it need to be on a timer? Is it just when you navigate back to that screen? Is it just once on load? There's a bunch of options. It's worth picking the most appropriate one. If using offline mode, within the last year or so, just over a year ago, it went generally available for some offline features, and it's much more valuable to do that than the coded approach of load data, save data, depending on your use case. So the offline one can actually have a very good performance as well, worth looking into. And also, this might sound silly, but even if you made no code changes or actual structural changes to your app, just by doing a republish to it, you're actually going to grab the very latest and greatest updates to the Power Apps engine itself, and it might actually provide some security and performance benefits because you're getting the latest and greatest of Power Apps. So something as simple as a republish on occasion might actually give you some benefits. So we did cover a lot there, so I appreciate you bearing with me. Again, I want to share as much as I can in this session because you're all smart people. You might know some of these already, but there might be some new things here and there for you. So next up, we're going to look at architectural optimization. So this one's a little shorter, this section. Now, there are ways, I don't do this too often anymore because there are other ways of doing it, but you can upload media to your Canvas app. So in the screenshot there, I've got some audio, images and videos. So we can actually upload these. It saves loading them from a source, or you've just got a logo. You don't want to grab it from somewhere. You just want to upload it, for example. If you're doing images, typically SVGs or scalable vector graphics are typically lighter, are typically much lighter actually than anything like PNGs or JPEGs or GIFs and things like this. The reason being scalar vector graphics, these are, as the name suggests, they're really just the vector mapping of what the graphic would be, which means it's really just like a little formula that's contained rather than all the pixels of an image, and it could be a big image too. So it means that because it's just the formula of it, that if you shrink it or you maximize it, it's going to keep that fidelity. It's going to be nice and crisp. And also they're much more lightweight because you're not holding all the pixels of a big image. If you are using Dataverse images, there's a great thing that they automatically create thumbnail images for you. This is useful if you just need very small thumbnails, say in galleries, you're repeating the records, and it provides it as a URL. So if you get that URL, you can actually just get that automatically instead of bringing back the massive images and trying to shrink them for a gallery. Again, graphics and images can be like worst offenders in file size, so this can be a good option to go with. Along the lines of the media and other things we might use within a Canvas app, we can actually remove any elements that we don't use anymore. So removing data, we've got this handy little button right there on the data tab on the left, where it automatically removes data not currently in use. So it means we're not having to go through the app and like manually check if something is used. We can say, oh, we did add a few things, we don't use them anymore, forgot to remove the link. You just click the button and it just like checks if there's any dependencies. And if there's not, it just scoops them up and removes them. It's great. Same with media, we just covered media, but that button's been around for a while to remove unused media. And the same with any unused flows. We don't need to trudge through and manually check whether flows are used or not. This button will just scoop up and say, oh, these are not used, I'll just get rid of them. The great thing with these and with anything not used is that if you don't need it, bin it. You know, anything we use within an app, Canvas or model driven, it requires memory. It might require memory to load when the app loads. It might need memory to say, I might use this, so let me get it ready for use by the users. So anything you don't need, it's worth getting rid of to clear the memory and make the apps more performant. Another thing I want to cover is the app checker. Now, many of us might be familiar with the app checker, but again, just for the benefit of everyone, I'll just give a quick demo of how this works. If we go to the top right hand side, we see this stethoscope icon right here. This is a way we can get to the app checker. And we're going to get a few different categories, performance being one of them. We can see here formulas, runtime, and a few others. And in brackets, just going to highlight if we've got any warnings or errors for these categories. So if I go to performance, which has a total of 11 warnings, luckily there's no errors in this case. It's going to give us any kind of warnings of, hey, this might hit your performance a bit. You might want to take some action or clean this up. So the very first one there is unused variable. If I click to drill down into what detail we've got, we can say, look, the issue is you've got an unused variable. It's not used. The location is on the app object. It's called global user. And how to fix it is we do this, we remove it, simple one here, and why we'd want to fix it. Again, this is not referenced by anywhere. It's not needed. It's going to take up memory. We just don't need it. There are other ones as well. These ones might be a bit more common, things to do with data. Say, hey, might be a delegation warning. We're not bringing everything back that we need to. Your data might get truncated, or you're bringing too many data, too many rows back. So here it's saying, look, your row limit for non-delegable queries is more than 500. You might want to think about changing this. Do you really need to do it? And again, giving us that good justification why we'd want to do this, so it can be a good education piece to learn, well, why is this the case? So really worth paying attention to them. It's just a tool out of the box. It's a good habit to get into using them as well. Another thing I want to use is the Power Apps Code Review tool. So this was created by the Microsoft PowerCat team. They often create really cool developer tools or very little useful utilities that help speed up development or improve what we're making. So with this particular one, this code review tool, this can review a Canvas app against a checklist of best practices, and it gives us a score like we're taking a school exam. So it might say, hey, you got 90%, which is an A, or you got 82% and it's a B. So it's a good way of kind of going through and seeing, well, what has this caught that my manual checks may not have caught? So it'll resurface those app checker results that we talked about a moment ago. There's an app analysis checking things like, well, what settings have you got turned on or off? What could be improved there? Are you breaching the recommended number of controls per screen, which might be, say, 300 per screen? Hey, you've got 400 on this screen. You might want to think about reducing it. And there's a code review that lists all screens, controls, and properties for any searches or filtering, again, where they can maybe be improved just to reduce the amount of data we're bringing into the app. So really cool. It can be a good part of your process as well. Would say, look, you might have a manual peer review, but do you really want to go over 30 screens that has 20 data sources and pages of code? Are you going to catch everything? Do you want to spend hours? Do you want to also run this, which might catch things that you might miss? I found it personally very, very useful. So yeah, great tool. Stepping back as well as an architect, I often think about, and I've seen this in my time as a pro dev, monolithic design. So a monolith or a big block, this is a term that's commonly used in programming to say, look, you've got this big block that does a lot of work, some maybe perhaps too much work. You might actually improve things by splitting some big thing into lots of smaller things, either smaller apps or microservices, they might be known as. So for example, with Dynamics, the CRM, field service, F&O, all these things are not combined into one big Dynamics blob that takes minutes to load and goes slow and it's clunky because it's doing too much. They've been split into separate products and separate apps. And it's something we can do with our Power Apps as well. So the concept really is like we really want something targeted that does one thing very, very well. It's a HR app. It's an event registration app. It's a timesheet app. Rather than, hey, here's one app with a menu with hundreds of options that you need to navigate and it just does too much. The other good thing with this as well, if you think, well, I want it all in one big app, so it's all contained in one place and it's slick. Well, we can still do that with individual Power Apps. We can actually navigate between them by using the launch function. So you might want to launch to another Power App by using its URL. So, well, okay, well, I want to kind of jump, from the John Smith record in the HR app to the John Smith record in the timesheet app. You can do that too. You can actually pass on the launch function some of these context parameters to say, here's my contact ID, pass this along. So when the next app loads, it will navigate to that contact record. You can actually have this smooth, slick, seamless experience going between apps if you need to. So yeah, it can be a great option. It means that the users aren't jumping in and out of apps between different browser tabs, remembering where the bookmarks are. You can just actually direct them exactly where they need to go. So while the bulk of this has really been about Canvas apps, because Canvas apps are by their nature very customizable. So by their very definition, it means that we can make a lot of really good decisions for performance, but we can also make some bad decisions for performance as well. It's really the power's in our hands and we might not be aware of the decisions we're making. With model driven, they really hold our hands a lot more and auto-generate and take care of a lot of these things behind the scenes for us. And there's a lot of good wins, but there's still some things that we need to watch out for. So some things like this form default tab, the controls there have got their initialization logic invoked on load. So if some of them are very complex, or there's lots of PCFs, or there's lots of things that do lots of heavy lifting, it might increase the load time to get into the app because it's all running when the app loads. If you've got any data-driven controls in there that actually go off to different tables, I always think about that with things like quick view forms, subgrids, timelines, many others. In other words, I've got to go somewhere else to get you that data. Then it's doing other queries to query these other tables and related data sources to bring all this extra stuff back. Because if you just go to a form and there's nothing else on there, it's just the form for that record, is likely going to be faster because we're not doing all the data pools. So it's worth bearing in mind how many of those types of controls we're having on there, and maybe not having too many. If we're using things like JavaScript as well, we might be getting a bit pro dev here, but using things like asynchronous network requests when requesting data, they're all kind of good ways of not having loops that are too busy or doing too much work. There's so many things we could do to make JavaScript performant as well, just to be mindful of. So yeah, a few gems there for model-driven apps, I hope. In terms of us as makers or developers, there's an optimization in our workflow and how we work as well. So one of them I like to mention from my days as a programmer is dry, or don't repeat yourself. One from a common sense point of view. But a few ways we can do this by using reusable items. So some of them are things I've covered so far, like named formulas. Again, that one thing there is available anywhere in the app. So I'm not having to copy and paste that code all over the place in different screens. It's just ready to go. The user-defined functions are mentioned there. We can pass in the parameters. We've also got some components as well in Canvas apps. We say, well, look, I want this same header on all 5 screens in this app. I want this footer in all 5 screens in the app. Instead of copy and pasting or reinventing it, we can just use a component where we change it once, it affects everywhere that it's used. If we've got these kind of objects that we want in multiple apps, let's say, well, we're developing 3 apps actually for my company, and we all want the same headers with the same logos and everything, we want it consistent, we can create those components in a component library. That way that multiple apps can benefit from that component library. So it's now more reusable for other apps as well. There's also Dataverse functions. These were also formerly known as low-code plugins. These are a way where we can actually have a snippet of Power Effects that we can pass in parameters and use in multiple places, not just Canvas apps, but throughout the Power Platform as well. So there's a lot more reuse for them. I would say they're still in preview, so I wouldn't recommend that we use them in production just yet, but we'll see what the future holds with them. My background as a SQL Server developer for the most part as well, I was used to this concept of normalization of data. In other words, trying to keep the data as structured as possible and not having any redundancy. So if I had an orders table and a customers table, I don't need the address potentially in both tables. I just need it in one place. I don't need the full customer name in both places. I just need it in one. I just want to kind of minimize where I'm storing that data, so I'm not doing too much. Now with SQL Server and other models, I'd often go a bit overboard with this kind of normalization. Now this is zoomed out. It's not meant to be readable, by the way, but I, often would use this kind of approach where everything has its own entity and it's very specific. I found that when I went to Dataverse, though, that I often didn't need to go to that level. Sometimes I needed something a bit more simplistic, or maybe there was a little duplication of data and it wasn't quite as neat as I've been used to. Now, that might be because Dataverse is determining those queries behind the scenes that I don't have control over. It's doing the work for me. So I actually can't fine tune the performance of some of these queries. So for me to go overboard with normalization sometimes slowed things down quite a bit. Whereas if I went for a simpler data model, I find that things worked a bit faster, but I might needed to compromise on that duplication of data. So just something to bear in mind. Trust me, I've been there. Sometimes simple questions as architects are the most valuable ones. Are your users close to your data? I might be a developer based here in the UK, but if my clients are wonderful people like you guys in New Zealand or elsewhere based in a completely different region, you as end users, you're the important ones using the app or the solution at the end of the day. You might have that long round trip to go over the network to pull data from a UK data center if I've created the environment there. That's not a good user experience. So it could be that when you create a new environment, what region are you choosing? Where you're based is great, but where are most of your users based? Have you got any data that's on your local network? If that's the case, you might have an on-premises data gateway. And if you do have one of those, again, where is that network located? It might be in a different region entirely. And that also goes along the lines where if you've got any kind of cloud services, let's say Azure SQL database, where's your resource group? Where are those resources spun up? Are they in the region where your customers are? Or have you been a creature of habit and chose your local data center? So it's just worth bearing in mind where that data is for those round trips over the network to get the data. So I'm just going to finish up. I appreciate I'm not far away before our next speaker, and you're certainly in for a treat because she's a great presenter. But what I'm going to do for the next 5 minutes is just go through a few other quick tips and tricks. So we talked about data sources. Now we've got a few options like an online data source, Azure SQL database, for example. SQL Server, let's say it's on-premise, the one we talked about there where we needed the gateway to communicate with it. Or Dataverse itself, which is part of the Power Platform. Now, really, if you've got any thoughts on this, I'll go ahead and give the answers. As if we were going to go to the online data source, again, let's say an Azure SQL database, the data call flow, we need to go through 2 layers. We need to go through something called API management or APIM, then the connector to get to SQL, then we're at the data source. So we need to go through 2 layers on the way there for the request, but then the response is 2 layers on the return. So I'm not saying it's slow, but it is slow. It's taking all these, going through these layers to get there and come back. If you go for an on-prem data source, we have a 3rd layer. We've introduced a new one, which is that data gateway. So again, 3 layers to get to the data source and then 3 on the return as well. So this one's even slower because we've had to navigate that cloud to local network traffic with the data gateway. If you go to Dataverse, this is the fastest way to access data, hands down. We have this direct connection. We don't even need to go through APIM or any connectors because it's part of the Power Platform. So by definition, this is the fastest way to access data at a data source. So surely that should mean it's the winner, right? Well, It does in terms of how fast we access the data, but there are other considerations such as what queries are being done at the data source, how big and powerful are the resources at that database. Are we using SQL Server where we could use views or stored procedures or functions? We might be doing things at the data source that Dataverse doesn't offer us at the moment. So while we can get to Dataverse the quickest, there may be other factors to bear in mind as well. In terms of data sources, we want to think about delegation as well. So delegation, the short version is where when you run a Power FX query in your Power App, we're actually doing all the filtering, sorting, and all the heavy lifting at the data source and just return the results back. So this is delegating all that work to the data source. That's how I remember this one. It took me a few reads when I was brand new to Power Platform, but I realized I'm delegating the work to the data source, gives me what I need, and again, just the required results. If we don't delegate properly, it tries to bring everything back and then do all the hard work in the app. So it's a cool thing. Dataverse has it, but other data sources like SharePoint, SQL Server, and Salesforce have it as well. Now, the example, it's not entirely, it's zoomed out a little bit here, but I've got a screenshot of delegable operations and functions for Dataverse. So if I look at an example to do an equals on a text value, it is delegable, which means it's going to be done at the Dataverse side. But if I do, for example, a search on a number, it's not delegable. So we're going to try and bring all the data back to the Power App and then do the search there. So we're going to try and stay as delegable as we can. Also, because we can, in Canvas apps anyway, we can bring up to the first 2,000 records back from the data source. So if you go to a table with 3,000 records, you might not be bringing it all back. We really want to delegate where possible. So just to finish up very, very briefly with some user experience options. The key one we talked very briefly before about too many controls on the screen. If you've got a busy UI, it's really not a great way to go. So controls require memory. So the more you've got, the more memory it's needed. It might be bringing back too much. There might be better options such as using gallery controls to repeat things. But it's not just the business data. You might want to repeat things like menu items and things like that. Or you might want to split the screen into multiple screens or multiple sections, multiple tabs. One for a good user experience point of view, but also this performance and point of view of bringing too many controls onto the screen. So another very brief demo I'm going to show here is if we do have something that runs slow, there are ways we can actually give feedback to the user. So here I've got a spinner on a screen that just says, look, here's a message, there's a spinner, look, I've done a load of testing, I can't make it any faster, it's going to take me 5 seconds, but I want the users just not to have a white screen that freezes. I want to give them this kind of feedback. So for this example, this is one of the modern controls, which is the spinner. Here's a similar example. It's called the progress bar, but we don't actually see what progress is being made because it's like Kit from Knight Rider. That's just aged me, right? But this is just spinning back and forth to say, hey, I'm doing some work. I'm like the spinner, but I'm horizontal. I'm just doing some work. And then another example of this, so I'll go to this, again, progress bar, but if I zoom in, we've got this property here called indeterminate. It's indeterminate because we can't determine how long something's going to take. It's indeterminate. However, we can also use this control, but make it determinate. Say, I know exactly how long it's going to take. So with this example I've mocked up right here, if I give this a run with this progress bar, I'm actually running through operations. I can determine the amount of % progress I'm making up to 100 when the operation is then complete. So there's a little bit of code in this. It took me a few minutes because I faked up an example here, but I've just said, look, take 10 seconds, but make it last 100%. So that's useful if you say, I know I've got 5 operations, 1 of 5 done, 2 of 5 done, and the user knows when that progress is being made. So again, same control, it's a progress bar, but we toggle off that indeterminate toggle to make it determinate. And again, we then need to code to display the text in the message. In this case, I've gone between 0 and 100 for %, but again, we don't have to do that. It might be 5 operations, it might be 3, it might be 10. It just depends what your use case is. So with that, I'm actually just going to skip ahead because I appreciate we're at time there, and I've been so keen to share so many things that I'm keen not to overrun because you're in for a treat with the next speaker. But what I'm going to do is just say the agenda, what we covered today was code optimization, architectural optimization, user experience, and monitoring and troubleshooting. Thank you so much for your time. Thank you for all the sponsors, all the other wonderful speakers and organizers of this event. If anyone's got any questions or you want me to help on your Power Platform projects, or you've got any questions about how you might use some of these performance tips and tricks, just please connect with me on LinkedIn. Always happy to help out. And with that, I hope you enjoy the rest of the event.